Okay,
So
so
this is part two, basically.
yeah, so yeah,
Cool.
we've gone through the the things that we can do to help utilize the the short-term memory, the working memory, long-term memory, to solve the problems that we have of trying to remember stuff, right? Um,
Mhm.
and and that's to handle issues when we are not at all familiar with the code, or there's something about it that we don't know it well enough. So we've got this third problem of code that is just too complex to understand. We can't cram it all in our brain. Um, so let's focus on that part, because that's really most of the code that we're looking at is code that I mean, especially if it's unfamiliar, we've got to cram a whole bunch of new variables in our head and new structures, and we don't necessarily know what that means. Okay, so we have our short-term memory, and this helps us remember information by sending it to a working memory. We associate it with the long-term memory. All right. Um, and then we have the working memory is used for processing that information that we have. And so working memory processes two to six things at a time. And of course, short-term memory can hold two to six things at a time. If you have more than that, we get what's called cognitive overload. I'm sure you know exactly what that means. So,
Mm.
um, what is this? Sorry.
Blank slide made its way in.
Yeah, sorry about that. Okay, so there's three types of cognitive load. You've got your intrinsic load, which is just how complex is the problem in and of itself. And then you've got your extraneous load, is what are the other distractions from outside the problem that make it harder to understand. And then the germane load is the cognitive load created by taking this information and cramming it into your long-term memory. So what does that look like? All right. So here's an example of, I guess, the least squares algorithm. So the intrinsic load is just your basic formula to draw the line we want. Y equals mx plus b. The extraneous load is the intermediate variables we create. So you got this, and the functions that we have to call. So you got the calculate b function. You've got this stream sum. You've got this variable here, the n, mean x, mean y. So you've got all these different variables that you have to keep in your mind to try and decode this. And then the germane load is trying to find a way to filter this down to the essential parts and associate them with something in our long-term memory so it can be stored there and then recalled later correctly. All right,
Okay.
so let's do an exercise of reading some unfamiliar code. And notice when you feel the need to make notes or take smaller steps, what kind of cognitive load are you experiencing?
I mean, there's a lot of variable names that are not not great in this, I have to say.
Yeah, so you've got like this. I is helpful.
Yeah, I can't
You,
stand the
yeah.
yeah.
Um, and then V, we reuse V here, which just it fills me with joy. Um, we've got these arrays up here, and they're being populated by global variables. That's always good to see. Um, this is this is a global variable, and so MST gives us an idea of what this is. It's a minimum spanning tree algorithm.
Okay, right. I guess the word graph would be the thing that sort of popped out to
Right.
me as like meaning tree of some sort.
Good point. Hmm.
Um,
So yeah, about that and visited or and maybe parent are about the only useful variables in here.
mm.
Um, but yeah, it's pretty complex.
What is it called? Sorry, I can't see the method name. What does it say up there?
Oh, up
There's
here
something
it's
on
called compute.
compute. Okay.
Yeah, very useful name. Okay,
Where did you get this from, this code?
I do not remember. I think I may have had ChatGPT generated. I don't know.
Nice, nice.
Yeah, or I found it on GitHub somewhere. There's a search engine to help you find specific code on GitHub, which is less useful now that you can just use ChatGPT to find it. So
True,
generate it.
true.
So anyway, um, what are the things that we would need to do, you know, to take code that's that cryptic and try and understand? Well, obviously, the first thing we would want to do is refactor it, right? So refactoring is changing the structure of the program without changing its behavior. You can refactor it to make the code more maintainable by breaking out a number of the reusable methods, but that could make it less readable. So when you do cognitive refactoring, you want to make it more readable so that you might well do some reverse refactoring or inlining. So basically you take code that was extracted out into a separate method, you stick it inline so that it reads straight from top to bottom. Um,
Okay.
and cognitive refactoring is normally a temporary thing. You keep any good ideas that you find, like any better names that you come up with for variables. But the point is that you're just trying to understand it and how it works. You're not trying to fix anything just yet. So I do this, frankly, I do this a lot for code that I'm unfamiliar with. You can also replace unfamiliar language constructs. That's, I guess, a similar thing to refactoring. Like if you're not familiar with uh, how lambdas work or how a
Mm.
stream works, but you can tell what it's trying to do, you can replace it with code that you understand. Um,
Okay.
or maybe even there's like an anonymous function in there, and sometimes those can be hard to read. Um, frankly, some
What are they,
people
sorry? Anonymous functions?
anonymous function, that's
Mm.
sort of the foundation for a lambda. It's
Okay.
a function that doesn't have a name. So
Right.
like you can pass it as a, yeah, you sort of pass it as a parameter, but um so yeah, just readability is in the eye of the beholder. So you do
Mhm.
whatever you need to make it more readable. And remember, you can always roll back. That's one of the wonderful things about having Git. Just get what I
Yeah.
had before. Um,
Is there a way, sorry to interrupt, is there a way to, because I know you can like extract a method in IntelliJ. Is
right.
there a way to then like
Uninstruct.
uninstruct? Yeah.
Yeah, it's called inlining.
Okay.
Yeah. So
Cool,
here
cool.
I have IntelliJ here. Let's just do that.
Yeah,
Um,
that would be useful.
let's go to some code here. Where's the project? Come on, project. There we go. And so, like, trying to find test utils get source directory dot set. So, um, I'm trying to find a function that we call here. Ugh, ugh. Here we go. So, like here,
Yeah.
If you can go like right click on this, go to
Mm.
refactor, and then inline field. Boom. Inline all and remove the field, or just yeah.
Okay.
So boom. So it's just taking it, and it's no longer an external thing. It's just inlined there, and it's all part of it.
Ah, right,
And
right.
then right.
That's brilliant.
Hmm.
What is this
And
Codium thing out of interest? Sorry, to change the subject. Codium
oh,
AI.
oh, well, this is something uh, I will probably be talking about this later because this is a really cool thing when we do refactoring. But this is a very cool tool um, that I learned about at our Java user group meeting last month. Um,
Hmm.
and it will look at your code and it will find ways to it will suggest refactorings that you could do to make it easier to read. And
Oh wow.
and you can then say, okay, yeah, go ahead and do that, and it'll go and do that. Uh, and so
Huh.
that's amazing. It'll also, you can tell it to look at your code changes and generate a check-in comment for me, and it'll do that for
Wow.
you. And it's yeah, so yeah, it's
That's cool.
called Codium.ai. You can go look it up yourself. And
Yeah.
and I recommend it. But like I said, I'm going to be adding it to our discussion for sure because it's a
Awesome.
really cool tool, and I've just started using it.
Yeah, that looks really cool.
Okay, so let me get this out the way. Okay, there.
Is this stuff you've been working on, by the way? The that
Oh, yeah,
or
this is approval tests. This is the open source project that I contribute to,
okay.
and yeah, I will be showing you that too. Not to worry. That's
Cool.
this is probably one of the most useful tools I've come across, and that's why I started contributing to it.
Awesome.
Um, so yeah, and so back to what we're saying, you want to replace unfamiliar language constructs with things that you're more familiar with. I mean, some people get confused by a ternary thing, the
Mm.
question mark colon for instead of the if then else statement. Sometimes that makes the code harder to read. So
Yeah.
if you do find yourself replacing unfamiliar language constructs, this is a good sign that you might need to spend some time learning them better. And so if you think about it, a 10x developer, you've heard that term, I'm sure.
Yes.
Yeah,
Yeah.
this is someone who works on the code so fast. It's because he has all that knowledge at instant recall. A 10x developer is usually the guy who wrote the program, right?
Mm.
So, but he knows everything about how it works. So using the skills that we've discussed, you can grow your skill base surprisingly quickly if you really focus on doing that. So these are all helpful tools that we can use to externalize parts of our brain that get overloaded. Um, so these, a thing like what's called a dependency graph. Um, you can basically show, okay, these variables depend upon this function. This function is called in these different places, and these are the variables that are used here throughout. So you can um, now this is a tool that Felina Hermans, she's the author of that book that I told you about. She created
Oh
this
yeah.
to make it easier to work with unfamiliar code. And she has this program organization thing that she's set up called code reading clubs, where she's encouraged people to get together and form code reading clubs, where you just get together periodically to look at unfamiliar code. And this is a way to sort of, like I like to print out code and draw lines on it this is a way to do this online so you can share the screen and have everybody work on it together. It helps you to highlight, function names and variables and draw lines and that sort of thing. We'll look at this in more detail a little bit later, but it's a really handy tool.
Okay.
Yeah, and
Annotate.
if you want to get to it, you can find it at annotate.codereading.club. That's the annotation tool. Actually, you know, they had I wish I had noticed this sooner, but they had a code reading club meeting this past week, and
Okay.
they haven't had one in a while, and so and they don't have another one scheduled. But if they do have another one, I will let you know.
Yeah,
Um,
I'd be really interested.
but yeah, if you go to codereading.club, this is the website, and it talks about you can find any events coming up right now. There aren't any. But also they've got the resources, which you've got your annotations tool, or you can take a piece of code from GitHub and print it out as a PDF, so it makes it easier to hand out to groups so everybody can look at it, like if you're going to have a code reading club at work and have everybody
Yeah,
scribble on the paper. Um,
that's
they
great.
they also have a GitHub repository that you can go to where they talk about, here's, if you're going to have a code reading club, here's what it looks like, here's the exercises you can do, and all kinds of neat stuff. So
Huh. That's
yeah,
really cool.
yeah, it is nice. So okay. Another thing you can do to reduce cognitive load is create a state table so you can keep track of the variables as they change as you're going through the application. I wrote this, I scribbled this out because you want to do it on paper. I don't know if that basically
Yeah.
you're gonna have, like, these are my initial variables for all these, and then the first time through the loop, these are how the values are going to change, and the second time through the loop is how the values are going to change. Um,
Mhm.
so, and like I said, I like to do this with a piece of paper on the desk. The you want to record each interesting state at each step along the way. If you skip a step because you know what's going to happen, it just prevents you from being able to discover any surprises that you may find in there. And so it's good to, you know, go through the extra effort to go and make sure you've got everything recorded to see how the trends happen to be. Of course, you can always combine both of these approaches, print out and draw a state table on the same sheet as you're working through the code and that sort of thing. Um, so there's no silver bullets. But as you practice, this gets easier, and these techniques can make the whole process a lot easier. Wait a minute, we're in a new world now. We can give it to ChatGPT and it'll tell us what the code is all about, right? Well, it can give an interpretation, and that interpretation will most certainly sound right. But unless you really know what's going on, you won't be able to tell if it's even close. And frankly, it's usually way off. I tried to see if, we were working on this approval test, and we tried to use ChatGPT to go and help us do the documentation. And we're like, at first, wow, that sounds really good. It was, oh, wait a second. No, it doesn't do that. No, that's not how it works. Oh, and this example code it provides, that won't even compile. Yeah, no, okay, this is dumb. so
Oh wow.
so yeah,
Yeah, I've definitely come across it like hallucinating like weird stuff.
right.
Yeah.
So yeah. So yeah, it's not quite there yet. Someday there might be an AI that can understand the code it reads, but not yet. So yeah, it's hard. And that's why you get the big bucks.
Yeah, we still got jobs.
Right. Okay, so some other interesting tools that we can use, your IDE it'll color the syntax in a helpful way so you can notice the variable names that you're using and the variable names that are global. You know, we saw that in the earlier printout of the code that we had. You can quickly see the structure of the code using that uh, the plugin that I can't remember its name for right now, but
Yeah, the one
um,
where it's comes up at the side.
yeah, yeah.
Yeah, yeah.
Uh, anyway, um, you and you can use the IDE to quickly jump to the definition of a function or where variables declared, or you can quickly find all the uses for a variable in the code. So it's important to know your IDE. Um, I'm I'm an old guy, so I still fall back on paper and pens regularly and highlighters,
Mm.
to draw things. You can use your debugger and set conditional breakpoints to see how the code works. If it's a particularly difficult issue and it seems to be using a lot of memory or a lot of CPU, you can use your profiler and check out the call stacks when it gets to a certain particular state. We always have our tried and true log files, right? And that's what we've used from the beginning of time. so, um, so all these techniques can help us to understand a small piece of code, and that's nice and all, but I usually need to quickly understand a large system. So, all right, let's take a step back now and look how we might do that, okay? Of course, we have to start with a small system, but what are the things that we do when we're trying to understand some unfamiliar code? We'll look at the variables. What does the variable contain? What's it used for? Is that name a useful beacon, or is it just something that is misleading? Um, so we can look at this code and we can look at the variables, right? So we've got there's four different variables. Their names are more or less unhelpful, but let's think about what are their roles. Um, so the number, we can think of that as it holds the most recent value, or the most recently entered upper bound from the user. Okay. Um, this we can think of that as sort of a stepper because it helps us step through the the loop. Um, it's also used as a parameter here, but its main purpose is as an iterator. Okay. Um, max prime factors. We can think of that as this is the thing we're looking for. This is our target. This is what our most wanted thing. Okay. So factors, we think of that. That's the most recent value. This is sort of getting us to where we want to be. It'll hold our most recent count of our prime factors. So great. What's with all these funky labels I'm giving them? Well, there's a researcher who's named Jorma Sajanini who determined that there are effectively 11 roles that will cover almost every variable that you come across. A fixed value is a value that doesn't change, like a constant or a read-only value or something from a database or a file. A stepper is a loop iterator or a side step. You know, you can have a flag that's an indicator something has happened, true or false. Okay. It's usually binary, but not necessarily. A
Mhm.
walker is used to traverse a data structure. So that's like where a stepper will increment an index. Uh, a data walker will increment by some unknown step, like it'll be a next pointer in a linked list or a
Okay.
tree or something like that. Your most recent holder holds the most recent value of something we're traversing. The last line that we've read, or the best value we've found so far, minimum or the maximum. Um, the I'm sorry. Yeah, the last line we read. Yeah, I'm sorry. I always get these two confused. The most recent holder. This is the one we're working on, and the most wanted holder is the one we're looking for. Right. As we're going
Right.
through the code or through our loop or whatever. A gatherer, it collects data into a single value. It's like you're computing a sum or something like that. If you know about the map reduce structure, this would be the reduce part of a map reduce.
Okay.
Uh, okay, a container is also known as a collection. Like a vector or an array list, that sort of thing. A follower would be the previous or next value when you're doing an iteration or a search. So it's where we're going to next. Organizer would be a temporary value that's used to transform one value into another. So that would be like the map part of a map reduce. You're going to change something from one to another. And then, of course, we've always got the temporary value. You're going to do swaps. So the interesting thing is that variable roles apply in every programming paradigm. It's in procedural programming, it's in object-oriented programming, it's in functional programming, it's in structured programming, it's in spaghetti code. And so this is these same variable roles are found everywhere. Okay, so I wanted to do an exercise where we look at some code and try and here, I have um, some code here, and I will just take this and put it in the chat.
Okay.
Um, and so you can look at it real quick. Yeah, I know that's
One sec.
long link, but it'll work.
All right, I'm in.
Okay. Um, so we can look at um, the look at that code, and I will look at it on my other screen and see if we can identify some of these roles. All right.
Okay.
So, like we've got this first thing that's a randomizer. My guess is that would be,
Um,
oh, that's what do you call it? That would be like an organizer that sort of transforms. So you're creating a random value
yeah,
from another value.
I was about to say the same thing actually. I think, yeah,
Okay.
it
And
seems like that.
params. If you go down to the
Mm,
bottom, you can see internal class params. So that would be, I'd call that a collection.
oh yeah, yeah, I see that.
Yeah, a container.
Uh,
Yeah. Oops.
Cool. What language is this? Sorry.
Um, I believe this is Kotlin.
Oh yeah. I was like, yeah, it looks sort of Java-like, but not
Yeah,
quite.
yeah.
Okay.
Um, Size looks like that would be yeah, I've not done this exercise on this code. This is just some code from our last code reading club. So
Cool. Size. What size do?
Size. Oh, that's what the randomizer gets assigned to.
Okay, yeah, I see that.
And do we, okay, and position.
So
Yeah, I'm not sure what that is. It's a holder of a most recent holder or I don't think it's the most wanted holder. Seems to be a holder of some sort because it's assigned a value and then used for something else.
yeah, I see that.
We got alpha is an integer of 255 originally. That may be a constant because I don't see it
Oh,
getting another value.
but then it gets randomizer.random in
Oh, look
like
at
line
that.
71.
Right, I see that. Uh-huh. Okay.
So
So
it
that is also,
starts as a constant and then gets randomized,
hmm,
which is kind of confusing.
yeah, yeah, this is I'm I had to leave the meeting early, so I don't know what this code is supposed to be doing. But it says snowflake. My guess is that it draws snowflakes on the screen.
Yeah, yeah, that's what I was sort of thinking. Seems like that.
Uh, so anyhow, so you can see how we can go and get the roles and knowing the general purpose of the function, it's helpful to help us figure out what the code's supposed to do.
Yeah.
But okay, so what about Hungarian notation? Have you heard of Hungarian notation?
I haven't actually, no.
Okay, so yeah, if you had, you'd probably be laughing at me. So uh, Hungarian notation was created by Charles Simoni in 1976 for a PhD thesis, and he was later hired by Microsoft and used his idea in Visual Basic. You've heard of Visual Basic, I assume?
Yes, yeah. I've never used it, but I've heard like of it.
Okay.
Uh,
Yeah, I've written a lot of
yeah.
Visual Basic. Um, so at the time, it was harder to see the type of the variable because the IDEs weren't as helpful as they are now. Um, so what
Okay.
people would do is say, okay, if it's a string, then put str in front of it, and if it's a number, then we'll put an n in front of it. And if it's a decimal, or like if it's an integer, we'll put an n, and if it's a floating point number or a double or something like that, we'll put the d in front of it. Um,
Okay.
and we thought that this would be helpful, and we quickly realized that it's not, and we stopped doing it. However, because I mean, if you need to change the type of a variable, it's really hard to change the name of the variable, especially if you don't have the refactoring tools in your IDE. And it's okay, we got to stop doing this. This is a dumb idea. If you read his paper, you can see that that's not at all what Simone had in mind. Okay.
Right.
Um, what we used to do is called systems Hungarian notation. And Simone actually described what we refer to now as apps Hungarian notation, where like C would be a counter of the number of instances. L would be like the length of an array. So he worked on Excel, so they use RW for row and COL for col.
Mm.
It's actually useful. And if you've ever done anything in Java Swing, you got an LBL, so you know this is a label control as opposed to the text that label contains. A
Okay.
TXT address is a text control as opposed to the text that contains. Um, so this is helpful to differentiate the control from the value. So this is the sort of thing Simone had in mind. And you'll notice that this is a lot like the roles that we've been talking about. So something to keep in mind. So who ruined Hungarian notation for us? Probably Charles Petzold in his Programming Windows book that everybody had way back when. back when 640K ought to be
Wow.
enough for everybody. Yeah.
When was this book written?
Well, this is Windows 3.1, so this would have been the mid mid to early 90s, something like that. Yeah, it was a long time ago.
Nice.
Um, so yeah, Petzold had us using str string and int_num and that sort of thing. We were just following his lead, and we were wrong, but
That
it's
must be
okay.
quite frustrating, like get someone telling you like you should do it like this, but then realizing like
Yeah, well,
actually that's useless.
yeah. Well, you just figure that, the book was actually indispensable for if you're going to be doing Windows programming because he showed you how to do everything. And we didn't have, you know, the internet was nothing like it is now. We used to get the Microsoft Developer Network CDs, 10 of them once a quarter, and go and install all of that so that we could go in and look stuff up for how to do Windows programming. Yeah, it was a different world then.
Is was that mostly like with Visual Basic, or is that what language would that have
Well, I
been?
was doing Visual C++.
Oh, okay.
Yeah, back when the Visual Studio was a brand new tool. And yeah, you'd install it, you'd have 10 floppy disks that you'd use to install it. And
Wow.
then it came on just like 5 CDs. And
Wow.
yeah, now people don't even waste their time on CDs.
Yeah.
Um, so yeah, so Simone's idea of basically putting the role as a prefix to the variables actually kind of helpful. Um, and with proper discipline and understanding, this could be helpful to use in your code, but most of your older developers will just get confused, and Windows Dev will get upset saying, "You don't do this. This is a dumb way to do stuff." So probably the young guys won't be as frustrated by it, but you can consider this. It might be helpful in how you name your variables. Okay, so understanding variable roles is just one more technique we can use for understanding code in the small. What if I want to understand what the developer was really intending to do in this big system? What's the big picture? Okay, so there's two levels we can understand source code. There's the text structure knowledge. There's your keywords, variables, syntax. And then there's plan knowledge, which is understanding what did the original programmer have in mind. Um, there's a lot of times I'll talk to somebody and I'll say, I know what you just said was English, but I have no idea what you just meant. That's kind of the question that we have here. So this is our minimum spanning tree code that we looked at before. And think about the process that you went through to try and figure it out before. So how do developers generally go about figuring out how a program works? Well, first we're going to find the focal point, right? This could be an entry point like main or onload function in a program, or just the beginning of a function. Um, it could be the line where a bug was reported or any other point of interest. It's the place that we start. The focal point is the most important thing. From this focal point, we can start building our knowledge. We might set a breakpoint or study the code, see what variables are used. What we can use the IDE or debugger to see where the code's called from. You might notice in the variables how they're used, how they're initialized, where they're declared. We have 4 class variables and 1 method variable. And then we've got 3 local variables, I, U, and V. Um, and these arrays, they're containers. N seems to be a fixed value. Where did N go? Yeah, right. So n is a fixed value. Um, so basically you can understand, where where we're where we're coming from. Um, these arrays here are used a lot. So this will give us a good understanding of the text structure knowledge. So that's good. Um, and now we can start looking at how things are used. Um, and even though these things are class variables, you can see that they're changed. The key is a class variable and it's changed here. Parent is a class variable, it's changed here. So this function has side effects. Well, that's important to know.
Mm.
All three of the loops go from 0 to n. This one, this one, this one. U seems to be more of a walker than a stepper, meaning that its value changes as we go through. Um, we dig deeper into how the different variables are used, and then we start to study these related areas, get a better idea of how it all works. So we've got these class variables that are maintained in here. We can see how they're used in other parts of the class. That would, I'm sure, be very instructive. We can see who calls this compute function, um, and what it's passed in a value of root. Well, what is that value when it's passed in? That would be helpful. We can dig into other related areas as well. Essentially, these are the 4 steps that developers will generally follow when they're needing to find new code. You're going to find a focal point, expand your knowledge from that focal point, understand some concept from a set of related entities, and then understand the concept across multiple entities. So we start small and just take bigger bites. But the
Okay.
key is that focal point. That's that is where you have to know where to start. Um, and that's where some frameworks and dependency injection frameworks or event driven programming techniques, they split things up and they make it hard to find that focal point, and then from there reach out to the related concepts. So in order, before you can really understand the code, you're going to have to understand how the framework or the technique you're using arranges things, so you have a better idea of where to look for things. Um, in those situations, it's easier to get the text knowledge, but the plan knowledge is really hard to develop and can be really frustrating. I mean, I can see what this code does and I can see what that code does, but what's it all trying to do? And you know, again, there's no really easy solution. You kind of have to just grind through it. Chat
Yeah.
GPT is not going to help you there. So, but with all that in mind, we go back to our idea of scribbling lines and circles in the source code to help reduce the cognitive load in trying to understand all these disparate systems. You circle the variables, see where the related variables, where the related methods and function calls are, the different class instances, draw a link between the classes and their instances. And how does this all relate to our 4 steps from before? Well, now we have a focal point to start from. Okay. When we first learned this technique, we just had this pile of code and we're drawing lines and trying to figure out what it all meant. Now we have a starting point and we have a clear objective. We can use this technique to learn just what we need and answer only the questions that we have. We don't have to know everything. It's hard to know everything, right? Um,
Yeah.
and so um, I will leave this as an exercise for you to practice uh, working through these 4 steps: finding the focal point, expand your knowledge, So I'll send that to you, and so that you can practice that on some code that you want to learn.
Okay.
Okay.
Yeah, that sounds great.
Okay. So now let's go back to this idea of reading prose. Okay. So how does reading code compare to reading regular text? It turns out that reading code stimulates your working memory, the parts of your brain that have your working memory. It also stimulates the parts of the brain used for reading natural language. So when people have had tests, um, when they're measuring the skills that someone needs to write a computer program, math skills contributed about 2%, and language skills contributed about 17%. And your working memory capacity and your reasoning skills account for about 34%.
Wow.
So those who tend to read better tend to write code more easily. In general, one's ability to learn a natural language is a strong indicator of his ability to learn a programming language. And this is surprising because computer science is considered a STEM subject. Most
Yeah.
college computer science programs grew out of the math program. So I find that very surprising. So
Yeah.
So let's think, what do we do when we read a nonfiction book or a newspaper? First, you're going to scan the text to figure out if it's worth your time to read at all. Um, you might look at any associated images or diagrams to help support what you are reading. Make sure you understand what you're reading. You might make notes to summarize what you're reading or highlight different sections of the text to refer back to later. These are all called text comprehension strategies. And this is what we learn in school. So they're probably automatic for most of us. Um, Now, by using eye trackers, researchers have found that when people read code, they tend to first scan the code to get an idea of what the program does. First 30% of their time is used to scan about 70% of the code. And that's very similar to how we read nonfiction. Um, Now, novice developers tend to read linearly, just straight top to bottom, about 80% of the time. That, or they'll just follow the call stack in the IDE. More experienced developers don't do either of those nearly as much because they're able to follow the call stack implicitly in their mind because they've done this much more. When you get good at it, it just comes naturally. Okay, so since
Mhm.
skills for reading natural language are similar to those needed for reading code, let's consider strategies for reading natural language more effectively. All right. So there's 7 different strategies for reading. Um, First, when you're reading something, you're going to activate. Activating. You're going to think of what things are related to what you already know. Monitoring, so you keep track of what it is that you're reading. You're determining what's most important. You're going to infer different things from what things that aren't explicitly said from what you're reading. You're going to visualize. You'll draw diagrams in your head or read text to deepen your understanding. You'll question, what does this mean? Why is this important? Come up with the questions that will naturally come up as you're reading it. Finally, you're going to summarize for yourself what I just read, so I can remember it. So let's go through each of these in detail. Um, so, all right, remember that when you think about things, your working memory is going to search your long-term memory for related concepts. So actively thinking about the code will help you to stimulate those connections. All right. So a good strategy is to do this, give yourself a fixed amount of time to study a bit of code, maybe 10 minutes. All right. And get some idea of what it's about. So, like you'll study some sample code for 10 minutes and then ask yourself some questions. What was the first variable that I noticed? Why did I notice that? What was the second thing that I noticed about it? Why? What? How are those things related? What concepts am I picking up in the code? Maybe some design patterns that I recognize, and what syntactic elements are present. Are they using lambdas a lot? Are they doing a lot of loops? That sort of thing. Am I familiar with these different syntactic concepts? What domain concepts, like design patterns, that sort of thing? What about the domain that I'm working in? If it's the financial industry, what are the financial concepts that are brought into the code? Or if it's the energy industry, what are the energy concepts? Um, it's good to do a little research on the unfamiliar concepts before you dive back into the code so you understand this better. So gaining knowledge about it all while it's still fresh is going to help you retain it better as you're working through it. And if you pile up a bunch of things that you don't understand, that's going to begin to increase the cognitive load and start to overwhelm you. So it's good to make sure that you understand what you're reading as you're reading it. Okay. Um, Next, monitoring. Okay, while we're reading some code, keep track of what you understand and what you find confusing. A lot of times it's helpful to print out the code. I find it helpful to print it out and annotate the lines you do or don't understand. Maybe you can use a check mark for the lines you understand and a question mark for the ones that you need a little more clarification. You can underline parts that are particularly confusing. Why do they use that variable name? Why did we do it differently here than we do it over there? And frankly, this can also be useful if you have access to the original author, you go ask him a question. You can clearly show him the parts that are confusing. Or you can share it with another person so that you can both try and dig through the code and figure it out. Next, determining what's most important. You go over the code, mark which lines are most important. If you're reading a printout, you might use like an exclamation point, say this is important, or circle it or something like that. Consider, why is this line so important? An interesting exercise might be, you have other members of your team look at the same piece of code and compare what they think is most important, and then discuss why they think that's most important. You can learn a little bit about how everyone approaches, how they try to understand some code. An interesting thought. Inferring the variable name meaning. So the variables are supposed to be beacons to help readers to understand the code, right? Any idiot can write code that a computer understands. The hard work is writing code that people understand. So it's good, pay attention to the variable names. If you find an unhelpful one like value, maybe you give it a more useful name. Good exercise. Go through the code you're trying to learn, make a list of all the identifiers, go through that list and determine which ones are related to the domain, like customer, and which are related to programming concepts. Because value is, who knows what that could be. But,
Yeah, that's a great idea.
Some can't be understood without some context. And some will require a little extra research, so you make a note of that as well. Notice when your domain and your programming concepts get mixed in the code. Notice which names are helpful and which ones are the ones you have to dig more deeply into the code to understand. Consider if maybe some ambiguous names are being misused. Maybe it's you can come up with a more helpful name that you could use to prevent that happening. Visualizing. We've looked at a couple of visualization techniques, creating a state table, following the stack trace. Another way of visualizing the program is to create an operation table. A lot of times you want to see how the variables are operated on, and that'll give you a better understanding of what's going on in the code. So That's another idea. You can ask yourself questions while you're reading the code, in addition to the ones that we already talked about. What are the most central concepts? What strategies did I use to identify? What's the what's the central computer science concept in the code? Is this a collection? Is what kind of algorithm are we looking at here? What can I determine about the decisions that were made by the previous programmers? I can look in the Git history and see how the code has changed and how did it get to be the way it is now? What assumptions do these decisions rely on? What are the benefits of the decisions that they made? Why did they make this change and why is it better? What are some of the potential disadvantages? Maybe what they put in to clarify doesn't really clarify it. And maybe I can come up with a better idea. Excuse me. Finally, you're going to summarize, right? You're going to make notes of what you've read, add comments in the code. I usually do that. Like when I'm reading through the code, if there's a complex piece, I'll put a comment in there that explains what it is and what it's trying to do so that I don't have to figure out again next time. I can come up with a better variable name. Some questions you might consider when you're summarizing the code. What's it trying to achieve? What are the most important lines of code? What are the most relevant domain concepts, most relevant programming constructs? What decisions did they make when they were creating the code? These are all useful things to consider as you're summarizing what it all means and cramming it into your long-term memory. So, okay. So in summary, we've talked about our three kinds of confusion: your lack of knowledge, lack of information, lack of processing power, and three ways to overcome that confusion. You can add more information to your long-term memory. You can increase your retrieval strength by practicing remembering stuff, and you can reduce cognitive load by creating an external instance of your computer, if you will. You can also read your code as if it were like you do nonfiction text. Find your focal point, expand your knowledge from there, understand concepts from related entities, understand concepts across your multiple entities. And then you can follow the 7 strategies of reading nonfiction text so you can understand your unfamiliar code. Okay. And so read some code.
That's I mean that's brilliant. Yeah. Thank you so much for that.
Yeah. I will say, and let me go back to the beginning here. That book, not those. Where is it?
Oh, the programmer's brain
Programmer's
one.
Brain.
Yeah.
I
I
I
need to get a copy.
I I didn't touch on a quarter of this book. It's got lots of really helpful information for helping you to write better code as well. So I strongly recommend you get the book and read through it. I found it really helpful, and I find it hard to remember all this stuff that I just talked about. And so
There's a
it's
lot
good
of
to have
stuff.
the book
There's a
there
lot
to
of stuff.
refer to remember all of it.
Yeah, for sure. I think I'm sort of now I've been introduced to this flashcard sort of
Mhm.
concept. I can imagine like going over these presentations and almost creating little flashcards from them. I think
Right, right.
that might be quite useful.
Okay, excellent, good idea. Yeah, that is it's sort of a power tool for us developers and helping remember stuff. So
Yeah. I was
okay,
reading that a lot of medical students use that technique as well for if they need to remember like massive textbooks and stuff like that,
okay,
which is pretty cool.
very cool. So yeah, so
Yeah.
I will put a yeah, later today. I'm going to I'm going to start using the Upcoach sites more
Okay.
and start putting this information up there for you, so you have access to it. And I I went to a seminar in how to use the tool better. It's like, holy cow, I am so doing it wrong. So I'm going to be doing it a lot better. And
What other stuff can you do on that? Like, is
um,
there
I can put quizzes in there. I can put uh, you know uh, keep track of of things that homework assignments that you're working on and that sort of thing. I can just I can add a lot more useful information. Like some of these images that I have here, the tables and that sort of thing. I can go and put those in there so that you've got access to it all uh, right
Mhm.
away. Um,
That would be
so,
brilliant, I think.
so yeah, I will be doing that. And
Cool. Looking forward
so
to it.
yeah, I because I said I was going to give you that one list for a homework assignment, and so I'm going to have to do that later this afternoon because I got to run to something this morning. But um,
Cool.
but I hope you found this helpful and useful. I know this is like my favorite uh my favorite topic
Yeah.
to talk about. So
I mean, yeah, this is the like there's so much to take in, but like I can already see how it's gonna help, the next sort of next bit of code that I'm gonna sort of come out without knowing anything. I think, yeah, I
right.
might even like just have this on like have the presentation sort of on the side just to sort of whilst I'm
Yeah.
going through the code just to sort of remind myself
Okay, I'll
of the
put the slides
concept.
up for you. How's that sound? I'll put a link to
Yeah,
the slides for you.
that'd be wicked. Thanks.
All right.
Cool. Thank you so much again. I actually love these sessions. Something I look forward to every Saturday. So
Fun. I'm glad.
yeah,
I'm glad. I try to make it interesting and fun. So I mean,
you've
it's all
yeah,
about helping you get better at what you're doing. So that's why I'm here. So
definitely interesting and fun. So you've done good there.
all right. Well, thanks much.
Cool.
And you have a great time at your girlfriend's house and her family's house, and y'all have fun. And we
Thank
will
you.
we'll talk to you again next week.
Yeah, yeah. See you again, same time next week. Hope you managed to sort your work stuff out and all
Oh
that.
yeah, yeah.
I'm sure you will.
It'll all work out eventually, one way or another.
Yeah. Awesome. All right. Well, take care. I'll speak to you soon.
Thanks. Bye.
See ya.